Hey everybody, this lab is about friction. So the setup is use a ramp. So here, like this, I'm just recycling the ramp I made for the projectile motion experiment. And then you're gonna find different objects. So different materials. Say 3 to 5 different materials. Say 3 to 5. So it could be, for example, like I have here this cardboard box of Jello. So it can be cardboard, wood, plastic, metal, what else? Maybe stone, like concrete, glass, rubber. So just different, like you can use ice, etc. Just different materials. So you don't need to test all, just pick 3 at least, but no more than 5, because I don't want you to spend your entire week just doing only this. And then you place that object up at the top of the ramp, and then you release it from rest. So start at rest. It's going to slide down the ramp some distance. Let's call this distance D, and then measure the time it takes to slide down the ramp. So make sure you measure this distance and this time. And this angle over here, because we also need the height here. Okay, so you could just measure the distance and the angle and then use trigonometry to get the height, right? Because that would just be d sine theta. Or you can just measure this height directly and then this distance directly, then you actually don't need the angle. So just measure 2 out of the 3 things. So definitely you need distance d, time t, and then the height over here. So you need these 3 things. And then do 10 trials per object. Because there's going to be error. So what you want to do is take the mean of those trials and then use that to compute the friction. And that's going to be the goal, is to compute the coefficient of friction for the different materials. Coefficient of kinetic friction. So mu k. Okay, so let me run through some of my sample trials. So I started off here with this cardboard box of Jello. So that's the kind of glossy cardboard, so it's pretty slippery. Right, so start up at the ramp, let it go, and then make sure you start at the exact same height every time using the same ramp. And then now I have this like Pringles can of potato chips. The bottom is metal. So here. And then I saw, oh, the lid is plastic. So I just flipped the can over and then I just slid it on the plastic lid. And again, same height every time, same angle every time. And then here's a shoe. So this was definitely pretty grippy. I could tell there was a lot of friction here. Okay, and now let's talk about how to measure the time. It's not going to be so easy to measure the time. So one way is just like really quick reaction, like with a timer, but I think that's going to be difficult. So I would recommend just video record the trials. I would just record it. That way you can just look at the video and then you can go frame by frame to get a more precise measure of the time. So I can walk you through what software I use. So when I edit videos like this one, I use video editing software, and a free open source version is called Shotcut. And I'll put a link in this video. So this is free open source and cross-platform, so you can run it on Mac OS or Windows or Linux. Okay, and here let's switch over and I'll show you how to use it. Okay, so this is Shotcut. And first you want to take the video that you recorded, and let me point out, you can record your video at different frame rates. So for example, like I'm recording all of my videos, for those of you who know cameras, I have a Sony Alpha 7 Mark II. So you can choose different frame rates to record, like 24 frames per second, 30 frames per second. Here's, like if I use my phone, like I have an iPhone, so you can go to this menu here and then get to the camera settings, and then see how you can record video or slow motion video. So if I click on record video, that settings, you see how you can record at different resolutions, 720, 1080, 4K, and then at different frame rates, 30 frames per second, 60 frames per second. So for this example, I recorded at 30 frames per second, and I'm just dragging my video down into this timeline here at the bottom. And this is 30 frames per second. So if you see where my mouse is, like here, right here, this is the kind of the timestamp. So see, if I advance like 22, 23, 24, 25, 26, 27, 28, 29, and then it goes back to 0 because it's 30 frames for every second. Okay, and then let's say here we're looking at the trial for the cardboard box. So here, let me back up frame by frame. If we can kind of just take a look at where did I first release the box? There, here, right? So starting from here, I'm just going to count the number of frames. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 10, 11, 12. Okay, so I would say that was 11 frames. So 11 frames divided by 30 frames per second equals the number of seconds it took to slide down the ramp. Okay, let's take a look at here, the metal Pringles can. So, and then just from my own qualitative observations, the glossy cardboard and the metal, they were both really slippery. So I'm not sure which was the winner. Okay, so right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 10. So 10 frames divided by 30 frames per second. So the metal looks like it was faster. It took less time to slide down the ramp. Okay, let's get to the plastic lid. And again, my qualitative observation, the plastic lid was definitely not as slippery as the metal or the glossy cardboard. Okay, so let's find right where I released it, right here. Okay, ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's gonna a little less than 12 frames, right? So let's say 12 divided by 30, that's the number of seconds for the plastic. And then over to the shoe. Okay, so this was definitely a lot of friction, my qualitative observation. Okay, so I released it right here. Okay, so ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 16. Okay, 16 frames divided by 30 frames per second. So now I got a pretty precise measure of the time it took for the object to slide. So I think it's not, I mean, I would recommend giving this software a try. I mean, this is not the only software, there are others out there, but this is the one I use personally to do video editing. Like I'm using this software to edit this video that I'm posting here. Okay, let's head back over to the whiteboard. Okay, so when you have all your data, I would just organize it into a table. So let's see. So this is all the time you measured in seconds. I'll just put it into a table. And then you're going to have 10 trials, right? 10 trials. And then your 3 different objects. 3 to 5 different objects. Okay, and then 3. Right, so all the time for the 10 trials you measure, because we want the mean and then the standard deviation, which from your last lab, you're pretty good at doing this kind of stuff now, right? For the mean, you just, in the spreadsheet, I would, again, just put this in a spreadsheet so that you can just use the built-in functions right here, average, and then you just highlight these cells here, and then at the click of a button, you got it, right? And then standard deviation, STDEV, and then you highlight these cells right here, and then click, got it. Then we're going to use these values. So these are the times, but the mean of the 10 trials per object. And we'll use this time together with this distance and this height to calculate the coefficient of kinetic friction. Okay, so we'll detail that next time. This week, just focus on setting up your ramp, finding your different objects, and collecting the data. So it might take some time. You saw how quick it was to use that software to count the frames. I think it's pretty quick. Okay, and then foreshadowing for next time. How do you compute the coefficient of friction? So it'll look something like, I mean, it was sliding down the ramp. So while it's sliding, what forces are acting on your object? Normal force, weight, and kinetic friction here. If you pick coordinates, I'm going to pick coordinates. I'm going to pick my coordinate axis in the direction that it's sliding, because I know that's the direction of the acceleration. Okay, and then just from the geometry, if this angle is here, that's over here. And now let's write Newton's laws decomposed. So in the x direction, mg sine minus friction equals mass times acceleration in the y direction, and minus mg cosine theta equals mass times the y component of acceleration. And I know the object is going this way in the x direction, definitely not any motion in the y direction. So I know ay is 0. Okay, the only acceleration is in the x direction. There's only an x component to the acceleration. Okay, and then we also know that friction is proportional to the normal force, right? And that constant of proportionality is the coefficient of kinetic friction, which is what we're after. Okay, so now if we just substitute here, n minus mg cosine theta equals 0, therefore n equals mg cosine theta, and then we put that here. Right, so this is going to be mu k mg cosine theta, and this goes right here. Okay, so let me write this equation. Mg sine theta minus friction, which is right here, mu k mg cosine theta equals mass times acceleration. So we have an expression for the acceleration. See how mass is non-zero, so we can divide by something that's non-zero. So the acceleration is here. Okay, so we have an expression for the acceleration as the object slides, and notice that this is constant, which means we can use kinematics for constant acceleration. So that's the one in the x direction, this one. And v. And then if you solve this for time and plug it in here, you get something that looks like this. Okay, so you take this acceleration and it goes here, right, and here. And then you start simplifying and then solve for this. So we can finish the story next time, but give this a try at least, to practice. Draw the free body diagram, pick coordinates, write Newton's laws. Okay, and then we'll go over the details next time, and then how to organize the lab report. Okay, so have fun with this experiment. Let me know if you have questions in the forum, and then I'll see you on the next video.